how many terms do we have here? Let's start with that. How many? 3 terms. What's the first term? Log of x. What's the second term? Negative 2. What's the third term? Log of quantity x minus 2. Anytime that happens, we have multiple logs, we have a constant. What do we need to move?
The log.
We need to move which log?
The one on the left.
That one.
The one on the left, because on the left-hand side we have 2 terms. We want to get the constant term by itself and the log term, move it to the other side. So we're trying to get this negative 2 on one side, everything else on the other. So we're going to subtract log of x from both sides. So now we have negative 2 equals log of x minus 2 minus log of x. Now what? Yeah, you're not missing anything. I'm sorry, what did you say? Yes, we do want to combine them. How? Yeah. So instead of 2 logs with a minus sign, we can write 1 log, and we can change this to a quotient of x minus 2 over x. Now what? I'm sorry, what? Rewrite it. Good. What's the base? 10 exponent. Logs equal exponents. That's negative 2. What is 10 over negative 2? 1 over 100 equals x minus 2 over x. Now what? Cross multiply. X times 1 is x. And then we have 100 times x minus 2. So x equals 100x minus 200. Subtract 100 from both sides, you get negative 99x equals negative 200. Divide both sides by negative 99. So what does x equal? 200 over 99. Now from this x, the domain is x greater than this one, 0. And then from this one, it's x greater than 2. So therefore, the total domain has to be x greater than 2. It's always x greater than the biggest number when they're all linear. Is 200 over 99 greater than 2? You bet. Okay. Last one.
I'm trying to follow this up.
Okay. This domain is going to be x greater than. Oops, sorry. X greater than 5. This is x greater than. This is x greater than. And this is x greater than. So the final domain, x greater than 5. Okay, so it's always the rightmost on your number line. Everybody good? All right, so we have all those. What can we do on the left-hand side?
Divide.
So we have 1 log base A of x minus 5 over x plus 4. And on the right-hand side, what can we do? Divide again. So we have log base A of x minus 1 over x plus 2. Again, notice we have 2 logs. The moment you take a difference of logs and you do a quotient, you now only have 1 log. Be careful because some people are still putting log over log. It's just 1 log. All right, what's the convenience now? We can drop the logs. All right, because we know that these 2 have to be the same. Now that these 2 have to be the same, what can we do? We can cross multiply. So we have x minus 5 times x plus 2 equals x plus 4 times x minus 1. And then here we get x squared minus 3x minus 10 and x squared plus 3x minus 4. Where do we go from here? What happens to the x squareds? Mm-hmm. Let's add 3x. And add 4. So we get x equals -1. That's great. Look at the domain. So the answer is no solution.
Is there a way to know there's no solution sooner?